of the greatest things about living in the Pacific Northwest are the trees. I mean, they're everywhere, these giant colossus that stand for the ages. They seem like they stand forever. So, you know, I've traveled around the United States a little bit and was able to see different parts, and I'll tell you, I really love the Pacific Northwest because of those trees. One of the coolest things about trees is you can carve into them, or not, that's terrible sounding, but you can take a core out and you can see the tree rings. And there are these layers that the tree builds up over time, and you're able to see what happened to the tree as it grew. You can see really dry seasons and really rainy seasons. You can see when a volcano may have erupted with an ash layer or a smaller region, not an ash layer, but a smaller portion. The tree records history for its life. There's actually a type of rock that does it too, and in this video we're going to be looking at a type of rock that acts almost like a tree ring for our planet. It records the history of our planet. In this video we're going to look at sedimentary rock. Now in particular we're going to do three different things. One, we're going to define exactly what is a sedimentary rock. Then we're going to compare and contrast the three different types. We're going to see what is a clastic sedimentary rock, a chemical sedimentary rock, and organic sedimentary rock. And finally, we're going to see how sedimentary rocks can contain fossils and record our history. So exactly what is a sedimentary rock? Well, a sedimentary rock is a rock that forms when sediments are compacted, when little pieces of other rock are pushed together. And in fact, one of your vocabulary words is sediment, and it's kind of the root of sedimentary rock. A sediment is a little bit of a broken up rock, or material. You could take something big and you make it little. And so sedimentary rock is just a rock put together of little bits of other rocks or other material. Usually they form in water, but they don't always have to. There is sedimentary rock that forms from the wind and the air, but most of them, the vast majority of sedimentary rock, you can think of them as forming in water. Maybe you've tried this. If you watch it in like a mud puddle, towards the bottom of it there's all this soil or silt and clays, things that are settling out, and they form this nice smooth layer. And that's an example of an early sedimentary rock. Over time that could build up and you get compaction and everything to build that sedimentary rock. Well, like we said, there's three different types of sedimentary rock, and they form a little bit differently. The first type is clastic sedimentary rock. This is kind of your normal, what you'd expect. It's made by fragments of little rock and they all get smushed together. It's a product of physical weathering, and so you could watch another video on physical weathering and see exactly what that is, but it's basically taking big rocks and breaking them into little tiny rocks. It's the majority, it's what you expect. These clastic sedimentary rocks, they vary. You could have something called a conglomerate, which has giant chunks of other rocks and is really coarse, all the way down to the finest little piece of sediment, and you might get a shale. So they vary. There's very coarse ones, very fine ones, and they're all formed by taking big things and breaking them up into little things. So we have clastic sedimentary rock. There's also chemical sedimentary rock, which is formed by chemical weathering, and you can go and watch that video. Chemical sedimentary rock is formed when rocks are broken down into solution. They're broken down and are dissolved away. You can almost think of it as a rock dissolving. It's changed. The chemicals have changed away. And when it changes into water, the water eventually evaporates and it leaves behind what it dissolved. It leaves behind a salt. Many times chemical sedimentary rocks are called evaporites because they evaporate to form. So we have clastic and chemical. And chemical sedimentary rocks are a little bit rare, but they're really important. In fact, giant wars have been fought over salt, over a rock, or a mineral in that case. And it's really an important rock. So we've got clastic, we've got chemical. Thirdly is the type called organic sedimentary rock. And an organic sedimentary rock is formed by pieces or shells or other pieces of life that fall and form a rock as a layer. Usually these are things like corals or shells or little outsides of little plankton, or forams, or even bone. You see, all these things are made up of something called calcium carbonate. And calcium carbonate makes for a really nice mineral. And as it falls out through the water, remember most sedimentary rocks are in the water, it forms layers, especially of the planktons and the forams. And you get layers of these shells and corals. you get layers of calcium carbonate. Over time, these form limestone, a really common sedimentary rock. And over time, that could turn to marble if it's a metamorphic, and on and on. There's giant areas of these limestones, and limestone and other organic sedimentary rock are really prone to acid erosion or more chemical weathering. So areas where you find a lot of limestone, you find something called karst topography, where you have giant holes or sinkholes that carved out from water and different acids. Fossils are another example of organic sedimentary rock. Remember, we said it's parts of life, and so as they form, you're getting an organic sedimentary rock. Ultimately, what sedimentary rock gives us in science is ability to measure and understand Earth's past. You see, as these layers form, whether it be a clastic or a chemical or even an organic sedimentary rock, they record what's happening. They create what we would call strata, and stratas are just layers. And by looking at the layers and examining where they're at and looking at fossils from within them, we can see and measure the changes in Earth. It's a lot like a tree ring. We can go into the tree and we can see what's happening in that tree's life. Well, with sedimentary rocks, we can see what's happening on the Earth. And we can use the different laws of geology, and you can use relative dating to give a timeline and see as the story of our planet. Sedimentary rocks are good and really an important way for us to understand our planet and understand our past. Well, in this video we did three things. The first thing we did is we defined a sedimentary rock. A sedimentary rock is a rock that is made up of little bits of other rocks. We can compare and contrast really the three different types. Clastic, which is made of little bits of other rock. Chemical, which is made from dissolving and then evaporating out. And organic, which is made up of different pieces of organic material, bones, shells, little pieces of plankton. We then saw how that sedimentary rock have fossils and can record our history because they're forming layers that help us understand, or strata, that help us understand our planet. So let me remind you how these videos work. Remember, you can always hit pause if things are going a little bit too fast. You can always backtrack and watch a certain section again, or just take a break and watch the whole thing again. But remember to always keep moving forward.